Hello, we're going to talk about the periodic table today. Hopefully you have just finished the Mr. X activity and had a really good time with that. The periodic table shows us this periodic pattern that repeats itself. Every now and again you will see a metal that will be very explosive with water. Every now and again you will see a gas that doesn't react. So periodically you see this trend, and so that's how it got its name. We are not going to call things rows anymore on the periodic table. We're going to call them periods. And if you look up here at your drawing, you will notice there are two red ones that they represent hydrogen and helium. They are in the same row, but we're going to call that period, and that is period 1. Everything in period 1 has one electron ring or one electron shell. They can also be called energy levels. So everything in period 1 has one has one outer ring. Everything in 2 has 2 outer rings, and so on. We're not going to say columns anymore. We're going to call them groups. And so if you notice everything over here in red, that is in the same group, or they're the same family. They share similar chemical properties. Everything there has a tendency to overreact in the presence of water. If you look over here at the purple ones, all of these are gases that don't react with anything else. So these are groups. They're sometimes called families. Now, if you are looking at periods, let's say we're going to look at this first column. It starts with red, and it just goes red, orange, yellow, green, blue, purple. And if you look at that, you will notice that I've said less reactive and more reactive. Within that first group on the left, if you have that family sitting at the table for Thanksgiving, there are some people at that table more likely to throw a fit than others. They are more reactive. Okay, as you go down the table, they become more reactive, and part of that reason, look at this drawing over here of all of the first 6 of these elements over here, and think about them as kindergartners. So if you have this group of, if every one of these yellow dots is a kindergartner and you're trying to keep up with them at the zoo, if you're at the top, you've only got 3 little yellow kindergartners, and so you're probably going to be able to keep up with your 3 yellow kindergartners. As you get down to the bottom, you can't even count how many little yellow kindergartners there are. You certainly can't keep up with them all. So if you think about it from that perspective, it makes sense that the things at the top are less reactive than the things at the bottom. It has to do with the radius of the atom, but that isn't something that we cover a great deal in 8th grade. As long as you understand that within a group, the less reactive elements are at the top and the more reactive elements are at the bottom, you're going to be fine. Next, we have groups. Red, you see here, is group 1. Orange is group 2. And as you go from the left side of the table, they are more reactive on the left and less reactive on the right. Every one of these elements wants a full outer shell. If they only have one shell, they want a full outer shell of 2 valence electrons. Everybody else on the periodic table is looking for that last shell to be full. And our electron configuration is 2, 8, and 8. We know that the first shell holds 2, the second shell holds 8, and the third shell holds 8. This first group only has 1 valence electron. Because they only have 1 valence electron, they're super reactive. But if you get over here to like group 6, they're a lot more mellow. They almost have a full shell. So if something wanders by, they'll be happy to react with it, but they're really not desperate for that reaction. So they become less and less reactive as they go. Now, when you get to the halogens, they have 7 valence electrons. So they're hyperactive. They really, really, really want to react, but they're limited in what they can react with. They want 1 more valence electron. So the only thing they can feasibly react with is an element that has 1 valence electron. So they are very, very reactive, but only with certain elements. And then our noble gases, nope, they're not going to react with anybody ever, ever. They don't do that. They are not capable of forming chemical bonds. In order to help us remember this, if you will write groups downward and periods across, it is a great memory tool to help you keep track of that. This first group right here, we are going to label those guys, and they are called alkali metals. We leave hydrogen out of that because it isn't a metal. It has one valence electron, but it isn't a metal. These are alkali metals. They really overreact in the presence of water. They have one valence electron, and they are desperate to get rid of it. They want it gone. They want to lose that electron in a chemical reaction with something else, and once it forms that bond, it will be content and happy. Alkali metals are our group 2. They are alkaline earth metals. Alkaline earth metals. Everything here has 2 valence electrons. They are going to lose those valence electrons when they have a chemical reaction. The next group are transition metals, and if you these are the things that you think about as being metals. Zinc, nickel, gold, silver, copper, titanium, platinum. Those are the things that we typically think of as metals. And transition metals are going to be all of your little short groups, plus those 2 groups down at the bottom. You will learn in high school more specifics about the group at the bottom, but for now, we're just going to call them transition metals. Over here is group 7. It's either 7A or 17. It goes by both labels. These are halogens. They have 7 valence electrons, and oh my gosh, they really want 1 more valence electron. So if you put them in the presence of an alkali metal, there will be an explosive and spectacular reaction. You've heard of a lot of these things that are a combination of an alkali metal and a halogen. The most common one is sodium chloride, sodium and chlorine. That's table salt, the salt we use every day. Hydrochloric acid is hydrogen and chlorine. So a lot of those are things that you encounter in your daily lives that once they've had that chemical reaction, they're stable and we're familiar with them. The last groups are noble gases, and they do not react ever. The word for a chemical that does not react is inert, I-N-E-R-T. They are inert and they don't react with anything. This means they don't even catch fire. They can't even burn because burning is a chemical reaction. They can't even do that. Our metalloids, if you will look at the stair steps on your periodic table, we're going to mark the things above the stair steps and below the stair steps. Now, across the top, it's boron, silicon, astatine, tellurium, and arsenic. Boron, silicone, arsenic, tellurium, and astatine. And then underneath the stairs, you're going to have germanium and antimony. I usually mark polonium as well. There's a little bit of debate over whether that's a metalloid or not. I mark it. It's kind of up to you. We do not mark aluminum. Aluminum is a metal. You know this. You have aluminum at your house. You have aluminum foil, aluminum cans, and so we're not going to mark that as a metalloid. The non-metals. I typically draw 2 stripes across my non-metals. If you will look on this chart, you will see the orange elements are the non-metals. Don't forget hydrogen. It's over there on the left. It's got 1 valence electron, and that's why it's on the left, but it is a non-metal. Everything else on the table, all these blue ones, are metals. Most of the periodic table is made of metals. So that's easy to keep track of. We don't typically color them just because it's more effort than it's worth. This is your finished product. This is what a Piton is going to look like. You will see everything that we talked about in the entire discussion, and everything is listed there for you. The things that you write on it, the things that you color, all of that. You'll see references to reactivity and all of those things. This is what I expect from you each time you complete a Piton. We will be adding more to this as the year progresses, but this is what you need for this unit.